Hey everyone! In this installment of our Sovol SV08 adventures, we are diving into the initial setup process and my first prints. Buckle up, because we'll also encounter a few interesting challenges along the way. Listen to these Z motors, for example, and listen to them after the fix. This will be a ride. I'm Gergo, and you're watching Gergo Print 3D, my YouTube channel dedicated to 3D printing and other DIY projects. Previously, we assembled the printer, connected it to Wi-Fi, and verified that all the motors moved correctly. They did move, but I ran into two issues that might leave you scratching your head. Thankfully, I was able to resolve one myself, and the Sovol team helped me out with the other. The first issue was the loud thumping noise the tool had made when it collided with the Y end stop during homing. It was a much smoother process in the X direction. Luckily, on a clipper printer, this is an easy fix. I simply adjusted the sensorless homing sensitivity parameter for the affected motor driver. I increased it from the default 65 to 75, and now it's perfect. Remember, this adjustment works not just on Core XY printers, but on any Clipper 3D printer using sensorless homing. Raise the value for a softer collision and lower it if the printer homes in the wrong position. The second issue was a real head scratcher. When moving the gantry vertically, I heard a rattling sound coming from the Z motors. I ran more tests, moving the gantry up and down, and the rattling persisted from all four corners, with the back two motors being the loudest. It was a very disturbing sound. I'll let you think about what could be causing this for a bit, but I will reveal the simple solution later in the video. Though Sovol assures me this was likely unique to my specific unit. For now, I continue the setup according to the user manual. There are two steps we need to complete before attempting our first test prints. The user manual dedicates a full page to filament loading and unloading, even though it couldn't be easier. Place the spool on the spool holder, cut the filament end at a 45-degree angle, push the filament through the runout sensor and PTFE tube until it reaches the extruder. Experienced users can already select the filament load command on the mini screen at this point. The nozzle will take a few seconds to heat up to the default 250 Celsius. While 250 degrees is sufficient for most materials, you can lower it in the global variable sections of the user editable macro CFG file. The parameter is called variable load filament extruder temp. I found it helpful to give the filament a slight push, but the extruder picks it up easily. You'll see first the previous and then eventually the loaded filament purge from the tip of the nozzle. If you want to purge more filament, you can select the load filament command again. But keep in mind, the default start print macro also includes a lot of purging at the beginning of each print. Once the filament is loaded, the nozzle heating will stop. I found this whole procedure to be very well thought out and user-friendly. I wish my T300 still worked this way. Unfortunately, they removed this functionality in the latest firmware. For the Sovol SV07 Plus and my clipperized SV06 Plus, the default clipper extrusion screen offers more options for heating and purging, but it's not quite as automatic. Unloading the filament works similarly, with the printer, very correctly, extruding a small bit of filament before retracting it completely, so we can pull it out through the PTFE tube. It might seem strange to load filament before the rest of the setup process, but you'll see why it is necessary for the next step. Next, the user manual instructs us to perform an Auto Z offset command under the leveling menu. And here's what happens. The bed heats up to 65°C before leveling the gantry. Thanks to mains heating, this takes about a minute even from room temperature. The print head is honed and the quad gantry leveling starts, making a few rounds around the four corners until all of them are at the same distance from the bed. The nozzle heats up to 200 degrees and the print head moves to the very back of the print bed. The system attempts to clean the filament of the nozzle, but with minimal success. I suspect the nozzle cleaning macro needs improvement. I'm not even sure if the nozzle was over the silicone brush during the cleaning process. This should be an easy fix though. The part fans turn on to cool the nozzle, and a probing process occurs in the center of the build surface. The nozzle is then lowered until it touches the force gauge load cell. This Z height is then compared to the level detected by the inductive proximity sensor on the left side of the tool head. This automated method replaces the paper method used on older 3D printers to establish the distance between the tip of the nozzle and the proximity limit detected by the inductive probe. The procedure continues then by probing an adaptive mesh for the included leveling test print in the center of the build plate. So this explains why filament loading was necessary for this step. The nozzle is kept below 150°C during the bed probing to prevent oozing. After the probing completes, the nozzle heats to printing temperature. Sovol's PLA presets use 235°C for the first layers, and the printer proceeds to print this 5-circle leveling test. This test pattern helps us evaluate the automatically acquired Z offset, which we can also adjust if needed. I lowered the print head a little bit because the automatic level seemed a bit too high for me. This automatic method isn't perfect, but it's slightly better than what most beginners would achieve with the paper method, so I can still see some benefit to it. I actually repeated the Auto-Z offset procedure a few more times, and each time I got slightly different results, so we do need to be aware of this. With the Z offset calibration complete, we can finally attempt our first test print. Sovol includes two 3D Benchy files on the USB stick. I chose the 12-minute variant. and it completed without any problems. Including preprint preparations, the total print time was 14 minutes. As you can see, bed adhesion is excellent, even on this smoother side of the build plate. The final result is very good, especially considering the high print speed. Cooling seems nearly perfect. I see minimal ringing or ghosting with the factory calibrated input shaper values. There is some loss of detail on the back and it's slightly under extruded on the top, but overall a very promising start. I'm confident we'll get even better presets eventually, but at the time of recording, the SV08 section of the Sovol website's wiki was still locked away. The USB stick included an older version of Orca Slicer for both Mac and Windows, along with instructions on adding the SV08 presets to an existing Orca installation. So that's what I did. Basically, I copied some files and subfolders to the Orca Slicer system folder, similar to how I recommended importing Cura profiles to newer Cura versions for earlier Sovol printers. It's not the most elegant solution, but hopefully by the time users receive their printers, the official release of Orca will have built-in SV08 presets. For now, we only get a single PLA preset with 2 process preset variations. All I had to do was enter the printer's local IP address, and these presets worked relatively well. However, I did dial down the speed a bit because I prioritize quality over speed. Others in the beta testing group simply used the Voron 2.4 presets with Sovol's Start G code. That works well too. To learn more about Orca Slicer and its impressive features, check out my earlier video dedicated to this software. The SV08 is Sovol's first printer to come bundled with Orca Slicer presets instead of Cura. I think this is a great decision. I've already printed several projects, some covering the entire print bed. I even experienced Filament running out, and the printer handled it gracefully, allowing me to feed in another spool. I also tested filament changes using the M600 command, first on a small print, and then on a full-scale model that took over 8 hours to complete. The final product has amazing surface quality with only a single minor Z-bending issue near the very bottom, likely caused by my handheld camera bumping into the print head. I was surprised nothing worse happened. Be very careful where you put your hands in this printer. Those motors are really powerful. We'll get this model painted in a future video, so stay subscribed. Finally, the built-in webcam works great for time lapses, although I did adjust the angle for a slightly lower view in future recordings. Now, let's address that Z-motor rattling sound from the beginning of the video. I bet you're curious. The sound was so concerning that I disassembled the printer entirely. I checked for broken bearings in the pulleys or damaged timing belts. As you can see, everything moved quietly on its own. Yet, when assembled, it made the same sound, even when moved by hand. And no, the synchronous belt wasn't rubbing on anything either. Upon closer inspection, you'll see Sovol applied Loctite to the grub screws a little too generously on my unit. Some of this glue ended up on the short belts and big pulleys, causing the sticky rattling sound. The Sovol R&D team came up with this diagnosis and they recommended the simple solution. Just clean the Loctite off the belts and pulleys using isopropyl alcohol. I share this information because you can easily check for this during unboxing. If any of your Z motors sound like this when moved, you can clean them before assembly. Instead of taking the entire printer apart, I only removed the top frame and gantry, which allowed me to move these motors independently. We can reach the belts and pulleys from the bottom of the printer and clean the glue off using Q-tips dipped into the same IPA, isopropyl alcohol, we use to wipe our PEI sheets. The results speak for themselves, or rather, they speak no more. Listen, the printer is almost completely silent now, and thankfully, it got even quieter after a few days of use. Apart from these minor teething problems, I'm truly impressed with the Sovol SV08. In the next video, we'll explore how easy it is to update the firmware, calibrate input shaping, and even perform PID tuning directly from the printer's small screen. I've also done various test measurements in this close to production unit. We'll also troubleshoot a few more minor issues, but that's part of the 3D printing hobby, isn't it? Hopefully you're subscribed to get notified about the next installments of this SV08 series. By the time you receive your printer, all these minor issues will likely be sorted out. And if you're thinking about ordering an SV08 or its accessories, please consider using my affiliate links listed in the description below. They won't cost you extra, but they do help support me and the channel. Getting ready for your SV08? These videos should help you prepare. You already have your printer? Then don't just watch, go print 3D. Thanks for staying all the way to the end.